Students, today we will discuss Newton's another law, that is third law of motion. The third law states that how the forces interact with each other. How the forces interact with each other. Newton's third law, it states that the interaction between two forces that they exert on each other, how they interact. Let A and B are two bodies. If the body exert a force plus F on the body B, then body B will exert same force that is equal in magnitude but opposite in direction, that is minus F. Means plus FAB plus FBA. মানে force exert on body B by A, and it is force exert on A by body B. If it is positive, then it is a negative. If a body A exert a force plus F on body B, then body B will exert force minus F on A. Understand? That means the magnitude of force are equal, but they act in opposite direction. And also, these forces act on different bodies. These forces act on different bodies. These two opposing forces are known as action and reaction. These two opposing forces, they are opposite each other. So we can write the two opposing forces are known as action and reaction. This action and reaction are equal in magnitude but opposite in direction. And also they act on different bodies and never act on same bodies. These two opposing forces, action and reaction, they never act on same bodies. They act on different bodies. So, Newton's third law states that the third law of Newton states that to every action there is equal and opposite reaction. Equal and opposite reaction. Understand? This is the Newton's third law. Here you observe that though the forces have equal magnitude, but the magnitude of acceleration produced by these equal forces are not equal. Why? Think it and comment box you write. Although the action and reaction forces are equal in magnitude, the magnitude of acceleration produced by these forces are not unequal. Why? Because these action and reaction forces act on different bodies. Because action and reaction act on different bodies, and these different bodies are have different mass, which have different mass, which have different masses. So the acceleration produced are not equal. Understand? Now we will discuss some examples or applications of Newton's third law. When we walk, what do? We press the earth with our feet, which is action. At the same time, the earth exerts a force on our body so that we can go forward. That means walking is an example of action reaction. Walking is an example of action and reaction. We push the earth with our foot, that is action. At the same time, earth exerts a force on our body in the forward direction, which is equal in magnitude but opposite in a direction. Similarly, while a swimmer swims, he pushes the water backward so that the water applies a force on swimmer in the forward direction, which is equal in magnitude and opposite in a direction. Water pushes backward, our body moves forward while we swim. So swimming is also is an examples. What are other examples? When a bullet is fired, the bullet applies a force in the forward direction. At the same time, an opposing force reaction act on the rifle or gun, by which the gun moves backward direction. The speed of the bullet and the speed of the gun are not equal because the mass of gun is far more than the bullet. So, bullet speed is more, but gun speed is less. This is called recoil of a gun. There are so many examples we can give. When jet moves upward direction, what happens? The hot steam comes out from the nozzle in backward or in downward direction with great speed so that the jet moves upward. This is an also example of Newton's third law, that is action under reaction. Also, when a air-filled balloon we release, the air inside the balloon rushes down and the balloon moves upward. These are all examples of Newton's third law. Now, you see, what do we know from three laws of motion? Now, what we know from these three laws of Newton? In first, that means we will know significance of Newton's laws of motion. First law talks about natural state of motion. That means if a body is in motion, then it will continue to remain in the uniform motion until the force is not applied. This is the Newton's first law. What is talks the second law? Second law talks if a body doesn't follow the natural state of motion, then the body is acted upon by an external unbalanced force. External unbalanced force. If the body doesn't follow the natural state of motion, that means the body must be acted upon by some external unbalanced force. In the first case, it states that definition of inertia, definition of inertia. What is inertia? I have discussed in the first video, and also and force. But second law gives the measure of force. It gives the measure of force. In other words, the first law gives the qualitative definition of force, but second law gives the quantitative definition of force. Now, what is third law states? Third law states the nature of force. The third law states the nature of force. That means that is the forces are always exist in pairs. That is action and reaction. And these pair of forces are known as action and reaction. These action and reaction are not acting on same bodies. They act on different bodies, which is equal in magnitude but opposite in direction. So the acceleration produced by these equal forces are not equal. This is all about the Newton's third law of motion. This, this is all about the Newton's three laws of motion. We make it in 3 videos. And another topic is there, that is law of conservation of momentum. In the NCERT syllabus only 3 laws are given, but it excludes the law of conservation of momentum. Those who are preparing foundation course, for them I will make a separate video that based on the law of conservation of momentum. And the numericals we will do in the next videos. If you like my video, share more and more, by which I will be inspired and other students also benefited by your sharing. So like my video, share and subscribe it. Thank you.